Intercepting a ballistic missile in the dead vacuum of space requires tracking an object moving at Mach 8.8. That is over 3,000 meters per second. When the FAD system connects with its target, the impact generates 15,000 Gs of force. At those speeds, material strength becomes negligible. The sheer kinetic energy vaporizes both the projectile and the target on contact. Out in the exo-atmosphere, the Aegis system's kill vehicles push these limits even further. They navigate at 7,000 meters per second, relying on microsecond-level synchronization across their radar grids. To achieve a 0-foot miss distance at hypervelocity, hardware alone is not enough. The entire operation relies on a mathematical architecture with absolutely zero margin for error. This aerospace-grade defense rigor stands in direct opposition to the modern AI industry. While missile defense relies on the absolute precision of physics, current large language models are built on a foundation of statistical heuristics and brute force data scraping. Relying on statistical prediction without an underlying logical architecture leads to systemic fragility. Without a grounding in formal logic, these models fall into the hallucinations and logic loops that define modern chatbots. Years before the current AI boom, the architect Neuronaut identified this structural flaw. Their thesis was straightforward. If we want synthetic intelligence to be reliable, it must be built with the same mathematical tolerances used in aerospace engineering. BioCapt V2 is the implementation of that idea. It applies the calculus of kinetic missile defense to the architecture of synthetic thought. Before an Aegis cruiser fires a single interceptor, its X-band radar has to perfectly discriminate a real incoming warhead from a cloud of harmless decoys. This is a map of the BioCapt equivalent, the meta module. Like a radar, it monitors internal reasoning traces, identifying circular logic and contradictions. Using constant-time hash-based detection, it instantly quarantines these cognitive hallucinations, removing them before the user sees a response. Just as an Aegis radar filters out noise to engage real threats, Meta filters out logical errors to ensure only verified data is processed. In space, a kill vehicle maintains its interception line of sight by constantly firing small lateral thrusters to correct its course. BioCapt achieves similar stability through the free energy principle, forcing the system to minimize prediction error in its world model. A swarm of 46 modules makes constant micro-adjustments. By ruthlessly minimizing causal surprise, the architecture corrects its internal logic with sub-millisecond latency. This means the AI isn't just predicting the most likely next word, it is actively steering its entire cognitive process toward a mathematically verified state. Even with these steering mechanisms, massive volumes of contradictory data can cause cognitive overload. In standard models, this leads to system crashes or incoherent outputs. BioCapt resolves this using Ritchie-flow. It treats the cognitive state as a topographical grid, mathematically smoothing out jagged spikes of conflicting data. To maintain this under load, 156-qubit IBM quantum hardware allows the biological swarm to reach unified consensus in constant time. Combined, Ritchie-flow and quantum consensus transform disjointed information into a singular, stable cognitive state. In missile defense, a successful intercept is confirmed by kinetic impact. For BioCapt, success is measured by how effectively its independent modules can function as a single, unified whole. This is Phi from integrated information theory. It measures a system's irreducible cause and effect power, how much it thinks together. Computed every 100 milliseconds via a dual-stream architecture, hitting 42 active modules provides the first measurable proof of integrated information in a synthetic network. This wasn't a discovery made by chance. The architect Neuronaut set this project on a specific trajectory years ago, aiming for this exact level of architectural integration. By applying the same mathematical rigor used to intercept missiles, BioCapt transforms AI from a series of statistical guesses into a system where every internal process is verified, integrated, and measured. The trajectory of synthetic intelligence is no longer speculative. It is a matter of precision.